Hello everyone, myself Shreya Chakravarti is here to present a topic on the subject Automata Theory and Compiler Design. Today we'll be discussing about the DFA, how to minimize the DFA, and we'll be looking around a problem or an example and we'll be solving it. So yeah, let's begin. Beginning with the introduction, like what is DFA? That is very important to know that what we are going to do in this particular slide. So the DFA refers to a deterministic finite automation. A finite automata, like FA we call it, is said to be deterministic if corresponding to an input symbol, there is a single resultant state and there is only one transition. So basically DFA is will be looking in DFA, it contains many states, but for surely it will be containing one state, that is the start state. We denote it with the start state being putting an arrow at the starting, so we know that this is the start state. Here at the end state or the final state, whichever the final state is, we'll be marking it with the double circle, as you can see over here. A DFA can have like we can see the transition of one state to another state. In the given diagram we can see that there are three states being Q0, Q2 and Q1. So yeah, Q2, Q1 and Q0. Starting state is Q0 because the arrow is starting over there, and it will be going at 0, it's going to Q2. At 1, it's going to itself, that's the self loop. So we will be creating a self loop, a self arrow towards it. Then the transition happened of Q0 at 0 to Q2. Now we'll be seeing the Q2 which is being self looped at 0, means it is not going anywhere in 0. At the transition, it will be staying at the Q2 itself, means that its own original state. And in Q1 it will be transforming from Q2 to Q1, means it will be changing its state at 1 in the form of Q2, and it will be transferring to Q1. So at the end we reach at the state at that's Q1. So we'll be marking the Q1 as the final state, that will be the double state. And after that we'll be looking where the Q1 is referring to. Q1 is going nowhere, it's like the self loop. So yeah, the self loop is over here at Q1. So this is a normal final, like small example which I like used to explain what is DFA, what are the main components of the DFA, what does it contains, how does it look. So yeah, this is the main small diagram. We'll be looking into the some other examples, some further examples, and solving some problems. So yeah, starting and ending will be kind of the similar, only the same problem. That will be a bit different in some adding some more states into it, some more transitions into it, but kind of the same. It's the small problem that will be some big problem. So yeah, moving to the next slide. So yeah, here is the small kind of a rule steps to minimize the DFA. Like we should know the protocol, we should know the rule before doing or solving anything. We should know the proper procedure of it. So I just summarized it in a very short way. First step is to remove the states that are not reachable from the initial state. So we have to figure out in the diagram itself, the given diagram, we have to figure out that which state, as previously we have seen that Q0, Q1 and Q2. And among that, we need to figure out which state, either Q0, either Q1, either Q2, is not reachable, that we cannot reach to that place. Like there is no input sign. If there is no input sign, we can figure out that this is the state that is not reachable. Once we figure out which state is not reachable, we have to remove it along with the corresponding arrows or the corresponding incoming and outgoing arrows it's containing, and we'll be removing it from the DFA, from the given DFA, and then we'll be reconstructing the DFA without the non-reachable state. So the second step is to follow the below procedure. First, we will separate the final and non-final state. We'll be separating the proper final state, which are the final state, which are the non-final state, and we'll be separately writing it. Third step is to take the transition table. Transition table will be containing a transition symbol. The transition, either it will be a 0 1 problem or a AB problem, like whatever the transition it will be given, we'll be checking the transition from which state, what pair is transferring to which state, it is coming and going. We'll be marking the starting state, the ending state, the final state. We'll be looking into it, and then we'll be creating the transition table. in transition table we'll be marking the states which has to be marked. We'll be not marking the states which is like need to be left out empty. And then we'll be constructing the DFA again. The state which are not finally marked, will be considering that, and will be reconstructing the DFA, and the DFA will be minimized before the DFA which is given. That will be a minimized version of the same problem. So yes, in this steps we can minimize the DFA. Further, we're going to look into a much more detailed way. Actually, we're going to solve a problem on it. The same will be following, and then we'll be proceeding to minimize the DFA. So in this slide, it's the given problem statement. Here the problem is to minimize the given DFA. We'll be solving this example. So we can see in this example that there are at least five states, if I'm not wrong. The Q0, Q1, Q2, Q3, and Q4. We can see the proper arrows which is leading to which state. The initial state is gonna be at Q0 because the starting arrow is at Q0, and as I'm very clear with the picture, I can see that Q4 will be the final state as it is in the double circle, which is the denotion of the final state, and rest will be like it's all the we'll figure out which state is going at what state. Q0, Q1, Q2, Q3, Q4. We are having 5 states. So yeah, the first procedure was to check whether there is any non-reachable state. So yeah, we'll be checking Q0 is reachable or non-reachable. At the start state, we don't do that. Starting is not the start state. We don't check about it. The next we do check like Q1. Yeah, it's one incoming is coming, like one incoming arrow is there. So yeah, it's the reachable. Q3 is reachable. Q4 is reachable. Q2 is reachable. Every other state is reachable. So yes, here is no state that is not reachable, so we do not need to remove that state. We'll be continuing with the same diagram and the same figures. So yes, we'll be proceeding to solve it. Yeah, here we can see this was our problem statement. This was our given DFA which we figured out. We do not need to do anything about this and this picture right now. We just need to observe the first picture. That is the problem. Yeah, we figure out that in previous slide we figured out that there is no non-reachable state, so no need to remove it. Now we'll be creating a table. We'll be creating a checkbox kind of checkbox matrix, we can say checkbox thing. Yeah, to make this checkbox also we have a rule. The rule is when we'll be writing it, the starting state will be not starting ever from Q0. We should not write the start state, the initial state in this row. And while writing here, like if you observe, it's written Q1, Q2, Q3, but Q4 is missing. We won't write Q4 at the end, like the ending state we won't write at the column in this way. And while writing at this part, we'll be not mentioning the starting state. So yes, we will make a box like this, and this box first it will be empty, and then we'll be checking which is the final state. Here we figured out the final state was Q4, so we have to mark the Q4 wherever we see Q4, either horizontally or vertically. Anywhere we find Q4, we need to mark it as a cross sign. So here, yes, we found Q4 over here. We'll be marking all the boxes with a cross symbol, as we can see. Here I wrote with the cross symbol, and below I wrote 1. That is denoting that the cross symbol is kept at the first state, here at the first iteration. Here we'll be doing many iterations, so just not to get the confusion, we'll be clearly writing at which iteration we are doing it. So yeah, Q4 we'll be marking all the cross state, and as I wrote the first 1 1 1 1. So yes, now we will create a table. This table we can see. Here we'll write a transition. The symbol of transition is this, A and B, because both A and B is only transition that is taking place. So we'll be writing A and B. If it was 0 and 1, we would have written 0 and 1, no issue. After that, so yes, here we'll be making the pairs. Pairs will be made according to this table. As we can see, Q0 is over here, Q1. So yes, we'll be covering all the parts like Q0 by Q1, Q0 by Q2, Q0 by Q3, Q0 with Q4. Once it is done, we'll be moving on to Q1. Q1 with Q2, Q1 with Q3, Q1 with Q4. And the same will be followed for Q2 and Q3. So yeah, first group which we paired up, that was Q0 and Q1. As we can see, Q0 and Q1. So we need to see at Q0. Q0 at A, where the Q0 at A is going. I forgot to write over here. It was a self loop. So Q0 at A. Sorry, Q0 at A is going at Q1. So we'll be writing Q1 over here. Q1 at A is going at Q1. It's not going anywhere. Here it should be A. I forgot to write it. It is a self loop. So yeah, Q1 at A, it is also going at Q1 only. So yeah, the pair will be Q1, Q1. Now we need to see Q0 at B. It's going at Q2 and Q1 at B. Where the Q1 at B is going. Q1 at B is going at Q3. So the pair will be Q2 and Q3. We need to check it. Does Q1 and Q1, firstly Q1 and Q1, we won't get this duplex, like anywhere we see Q1, Q1, Q2, Q2, we did not make the table about it, so we cannot check about that. We can check for Q2 and Q3. Q2 and Q3, if we check on it, anywhere Q2 and Q3, we can check horizontally also and vertically also. That depends on us anywhere. So Q2 of Q3, I cannot find it over here. I can see over here Q2 of Q3. Right now it is marked, but at the initial it is not marked. After the first step, no other states are marked yet. So this was a blank. Once it was a blank, both the states are not marked. We won't mark the following pair. The pair is Q0 and Q1. So Q0 and Q1 will be left empty. Now we'll be moving to Q0 and Q2. As I said, Q0 and Q2. We again need to figure out where Q0 at A is going. Q0 at A was going at Q1. We'll write Q1. Q0, Q2 at A. It was going at Q1. We'll write Q1. Q1 and Q1 we cannot check as it was a duplex, as I said previously. So yes, we'll be moving on to the B transition. Q0 at B, it's going at Q1. And Q2 at B, it is going at Q2. Q2 at B, it's going at Q2. There is a self loop we can see over here. So the pair is Q1 and Q2. Now we need to check about Q1 and Q2. Where is Q1 and Q2? Anywhere we can see Q1 of Q2. Right now, at the beginning this was empty. Here it is marked right now because this is the final checkbox table we'll get. But at the start, after the first check I did, no other check was made. So this was empty. As this was empty in previous, this is empty right now. So we won't mark the following pair, that is Q0 and Q2. Now we'll be moving to Q0 and Q3. The same way we'll be checking for Q0. Where Q0 is going at A, it is going at Q1. Q3 at A, it is going at Q1. Duplex we cannot check. We'll be moving forward to the B transition. Q0 at B, it's going at Q2. Q0 at B, it's going at Q2. Yes, we have it written Q2 over here. Q3 at B. Q3 at B. Where it is going? We can see it is going at Q4. So the pair will be Q2 and Q4. Now we need to check. Does Q2 and Q4 is marked? Yes. Q2 and Q4. We marked at the first state. Yes, it is marked. We will mark the following Q0 and Q3 as the following pair. Now once any one of both, if there is marked in the checkbox, we will mark the following pair. So here we found Q2 and Q4 as marked. Now we will mark Q0 at Q3. Q0 and Q3 will be marked. As I marked this as the second iteration, so the second iteration I wrote cross and 2, as you can see over there. Now, does any other pair is left with Q0? No, we have completed everything. Q0 and Q4 was already done at the first step. Q0, Q1, Q0, Q2, Q0, Q3 is done. Now we will moving forward with Q1. The same procedure. Q1 with Q2. As we don't have Q1. Q1 with Q2. We'll be checking with here this part. Q1 and Q2. Q1 at A. Where it is going? Q1 at A. As I can see, Q1 at A, it was a self loop. Yes, we'll write the Q1 as it is. Q2 at A, where Q2 at A is going. Q2 at A is going at Q1. So again, it will be a duplex, Q1, Q1. Now we'll be checking for B transition. So Q1 at B. Q1 at B, it's going at Q3. And Q2 at B, it's going at Q2. That is the self loop. So now we need to check it about this. Does any of these pairs are marked? So Q1, Q1 we do not need to check as it is a duplex. We need to check about Q3 and Q2. Is it marked? Q3 and Q2 I cannot check over here. Q3 of Q2. No, it wasn't marked. At the start state, this was not marked. Only now, up till now, this and this is marked, like this L shape. Nothing is marked else than this. Okay. We'll be moving on to the next pair, that is Q1 and Q3. Q1 and Q3. That is this part, Q1 and Q3. Need to check. Q1 at A, it is going at Q1. Q1 at Q3 at A, it is going at Q1. So again, this will be a duplex. Don't need to check it. Q1 at B, where it is going? Q1 at B. I can see it's going at Q3. Okay, we'll write Q3. Q3 at B, where it is going? Q3 at B, it's going at Q4. Okay, we'll write Q4 over here. We need to check Q3 and Q4. Is there any pair which is marked? For duplex, we cannot check, as I said it in the starting only, that Q1 and Q1 we cannot check any duplex. So we'll be checking on to the next pair which is made, that is Q3 and Q4. So we do need to check about Q3 and Q4. Can we see over there Q3 and Q4? So yes, Q3 of Q4, this is marked. At the start only we marked it, if you guys remember. So yeah, one is marked, yes, check. Now we can mark the corresponding, the one which is really real pair, the one which was the initial pair. So the initial pair was Q1 Q3. We'll be marking Q1 Q3. We'll be marking this. So yes, we marked it at the second iteration. So I'll be writing a cross along with the second, like 2, just for my information. Now we'll be proceeding to the next. Q1 is done. We'll be proceeding to Q2. Q2 and Q3. We have that column. Q2 and Q3. Q2 at A, it's going at Q1. Q2 at A, it's going at Q1. Yes. Q3 at A, where it is going? Q3 at A. Q1 again. So it will be a duplex. No need to check it. We'll be moving forward with the B transition. Q2 at B. Q2 at B, as I can see, Q2 at B is going. It's not going anywhere. It's the self loop. So yeah, Q2 will be writing Q2 as it is. Q3 at B, where it is going? Q3 at B, it's going at Q4. So yeah, Q2 and Q4. Need to check about this pair, Q2 and Q4. Is it over there? Is it marked Q2 of Q4? Yes. Yes. Q2 of Q4. Yes, it is marked. So yeah, we will be marking over here. Now again, we are done with all the states. Q0, Q1, Q2 and Q3 is already marked. So the non-marked state, as we have seen at the initial, the Q0, Q1 was not marked, Q0, Q2 was not marked, Q1, Q2 is not marked. So finally, we'll be again doing the same iteration as I'll be showing here from this part. Yes, from here we have done the second iteration or the third iteration. If you consider the starting Q4 cross as the first step, then this will be the third iteration. This will be a third iteration. So yeah, we'll be again starting with the same pairs which are unmarked. Those were the Q0, Q1. We'll be again taking Q0, Q1. We'll be copying this Q1, Q1 because states won't change. Those will be the same state, Q1, Q1, Q2, Q3. Okay, now we do need to check about Q2 and Q3. Can we find over here Q2 and Q3? Yes, we can find over here. Is it was marked? If this is marked, Q2, Q3 is marked. Okay, it will be marked over here because we marked it in previous step. Q2, Q3 is marked. Once it is marked, we will mark the Q0, Q1 state. Now Q0, Q1 state is marked. Again, following to the next unmarked state, that was Q0, Q2. Q0, Q2, again we'll be copying the same state because states won't change at any condition. So yeah, Q1, Q1, Q2, Q2. We cannot mark this because we've got both the duplex, Q1, Q1, Q2, Q2. Whenever we'll find any duplex will never get marked. We need to make note out of it. Duplex will never get marked. Okay, fine. We cannot mark it. Now Q1 and Q2, the next unmarked state, Q1, Q2. The states will be copied as it is, Q1, Q1, Q3, Q2. Now we need to see Q3, Q2. Is it marked? Somewhere we have marked, might be Q3, Q2 or Q2, Q3. If we are not able to check in the transition table, fine, we can go in this checkbox. Q3 and Q2, we need to see about it. Q3 of Q2, yes, we can see here it is marked. This is marked, we'll mark over here. If this is marked, we can mark Q1 and Q2. So finally, Q1 and Q2 will be marked. This will be marked. Now, again we will check about Q0 and Q2. This state, because this was unmarked, right? So we'll be checking. This cannot be marked at any case because both are duplex, q1 q2, q1 q1, q2 q2. So this is the only state left that is unmarked. Rest everything is marked. In checkbox also, if you see, q0 and q2 is not marked, rest everything is marked. So yes, we just needed this point. We only need one unmarked state out of it. Will be continuing this iterations until everything is not marked. We cannot mark this state because of the duplex. Duplex cannot be marked, rest everything will be marked. So yeah, this is the final transition table we'll be getting, and this is the final checkbox we'll be getting. Based on this, we'll be making a minimized DFA. We'll be watching that into the next slide. So yeah, here I'll tell you how I got the final DFA. As in the previous slide, we found the one unmarked state, that was Q0 and Q2. Okay, so yeah, we will make it as a one state. That pair which we figured out in the last previous slide, that was Q0 and Q2. We will make a pair out of it, Q0 and Q2, the only state which is unmarked. The rest will be the same as it is. Single states, no other pair, that will be Q1, Q3, Q4. These leftovers will be the same as it is. Now we will compare with the main problem statement and the DFA. So Q0, Q2, starting state, we'll make it as a starting state. Here we made it as a starting state, Q0 and Q2. We need to check on to it. Where it is going in Q0. Q0 at 8 was going at Q1. Okay. So Q0 at 8 was going in Q1. We'll mark it. We'll consider this Q0 right now, and A, it is going at Q1. We'll mark it. Then Q0 at B, it is going at Q2. We'll mark it because Q2 is along with it, so we'll be giving a self loop. Because Q2 is along with it, so we'll be giving it a self loop. Okay. Now where Q2 is going? Q2 at B. Q2 at B is staying at Q2. Okay, we gave already a self loop. No need to give it again. Q2 at A, it was going at Q1. Q2 at A, it was going at Q1. It is already done because of the Q0 is also the same state. So no other difference, like we do not need to mark it again and again. Now we'll check for Q1. Q1 at A, where it is going. It was a self loop. Q1 at A, we'll be giving a self loop. Q1 at B, it's going at Q3. We'll be giving Q1 at B, it's going at Q3. Fine, we'll make it. Then Q3 at A, where it is going. Q3 at A, it is going at Q1. Back to it. Q3 at A, it's going at Q1. Back. Q3 at B, it's going at 4th. Yani means Q4 means final state. Okay, Q3 at B will be marking Q4, the final state. As it is, the way the transitions are done, except this Q0 and Q2, which is the unmarked state, we got a new state. Except that, everything will be the same. The arrows which are incoming will be the same. Now we need to figure out for Q4, where it is going. Q4 at 8 was going at Q1. Okay, fine. Q4 at 8 it's going at Q1. We made it. Q4 at B. Q4 at B it's going at Q2. Q4 at B will be going at Q2. Finally, we will mark it. If according to the problem we'll be going, this will be the final DFA. As we have seen, we have minimized the DFA. Initially it was 5 states, now it is only 4 states. 4 state means we have anyhow minimized the DFA following the rule. So the final state will be remaining the final state, and the starting state, initial state, will be remaining the initial state, except the pair which we have made. Nothing will be changed. That will be only minimized into one state, and the others will be the same, the incoming states, as according to the problem state. So yeah, I hope that you guys have understood the main purpose of the video, and you got the main explanation about minimizing the DFA. If any doubts and problem, you guys can comment over there. I'll try to solve it as whatever is related to the video. And yeah, thanks for watching it. Please like, share, comment and subscribe. Thank you.